to talk about Reහැ today. So before that, I have a confession to make. So I know this conference is filled with all generative AI talks and data talks. Sort of when I have to talk about something which is not related to AI or data, I sort of feel a little outdated. I hope some of you can empathize the feeling. It feels like, I'm trying to buy a fossil fuel car when electric cars are on the rise. But the interesting fact is, the first electric car was made around 1823, which was 200 years ago. And still we see these fossil fuel cars in production on the road. So while I wish, of course, these fossil fuel cars to go extinct as soon as possible, and also curious how AI is going to shape up our software and how maybe APIs might be replaced. But today the talk is not about AI, it's going to be on good old APIs that we have been used to, and how we're going to automate that. So coming to this term API first. So API first has been a buzzword, I guess, maybe a decade ago, when all the companies are trying to move to being API first or API design first. I think today it sort of feels like a first thing to do, but back then it seems like people were code first, like only they used to think API as an afterthought when they have to sort of integrate those systems to, let's say, with other systems or expose their service online. But today it sort of feels like super redundant. But now today the good thing is almost all the services are API first with the advent of cloud, and of course Salesforce was one of the pioneers. We have everything in Salesforce is an API, even a database table has an API. So that is the world that we are living in. But it's also important to know that we can't sort of develop an API which is future-proof with everything ideally present with all the future requirements in mind. So it's important that we got to iterate it. So of course, when you're trying to iterate things, you got to have something to guard your API that it's working as expected before you expose it to your integrations or end customers. And what would do that job? Is it the documentation? Of course, documents are the first thing to get outdated always. Whenever somebody asks me about a document that talks about API, I always have an outdated document, of course, when API is in development. And it's always an afterthought. The doc writers come towards the end and write documentation. So that's not the one. And maybe it's the developers, but they do change. They do change themes, and even product managers leave. Everybody sort of, even the very product might go to a different company. The one thing that sticks with the API and makes sure that it works, it does the job as it is expected to, is API automation. API automation, of course, is like you have to programmatically run your APIs such that they're close to what an end user would sort of use it like. So somebody who's not familiar with it. And it's important that we left shift API automation, like it start having a strategy for API automation along with your APIs. So with that said, this talk, although it's like API automation, it's not like catered for just QA engineers or test engineers. It's writing tests is a developer's job too, and there is like that overlap, beautiful overlap between testers and QAs, and this talk fits right in that overlap. And I'm of course the lead developer in Salesforce, and this is my X handle. It's kind of funny to say X handle. It's current X handle. It's no more Twitter. So, and this is my website. You can find more of my talks and the libraries that I've worked on my website. And feel free to reach me out on my Twitter. Like, you can just DM me if you have any doubts after this talk. And of course, this is Salesforce that you can sort of scan this code, give us feedback, and you will be added to the raffle that's going on outside. One thing Salesforce is great at, one of the things is giving goodies, so don't miss them. Please scan this code and then fill your feedback, a short feedback, and then that will be helpful. So one of the ways we do our automation is we have multiple ways to do our API automation. One, of course, manual testing. Nobody can beat that. Even most of the bugs we sort of like it's generic, it's not specific to one organization, but manual testing does uncover until, I guess, humans are replaced by AI. And then integration tests and end-to-end tests. These are sort of pretty close when it comes to testing. They almost have the same code path in a different way. Of course, side tests, integration tests are more granular. But the problem comes when they take alien forms. For example, I have worked with multiple organizations in my career. So wherever I go, I've seen a different automation framework. And every team I join has a different automation framework. And when I have to take up a new code base because the code base got shuffled and got to our team, there is some complex automation framework that we had to ramp up. And so we end up in this state. So production code is great, but always test code is that shady area where you don't want to touch because it's sort of nobody knows what's going on. The problem there, when you think about it, tests, these automation frameworks that are written that are custom to a specific service are okay. I mean, on the name of flexibility, they may have what they want to test for that service, but they're pretty rigid to that particular service. And they're not reusable because they have not started having reusability in mind to start with. So of course, they end up being rigid to extent, difficult to maintain. And of course, how many of us really design tests here? So we don't focus, we sort of burn a lot of meeting minutes designing production code, but not a lot of us spend time on test code. Still, tests are seen as something which don't add business value, which is unfortunate. And last but not least, the problem with adding up all these problems, what happens is towards the end, these tests deviate from what the end user would use, and they no more are honest to what they're supposed to do. And at that point, they sort of become, developers take these hacky shortcuts to just fix them and put a band-aid every time they fail. And after a point, they just become complex, useless, and they become a food chain to the development rather than aiding the development or driving the development. So with these problems, again, the clicker stopped working. Yeah, so the production code becomes cognitively complex compared to the test code becomes more cognitively complex. And at that point, that's where maybe the argument comes in wherein, hey, the tests don't add any business value. We are not able to focus on real prod code which adds business value because of the tests. And they sort of becomes an afterthought. And that, of course, applies to any test. It's not just API testing. And so what I'm suggesting is, let's solve this with a new framework. So that's ironical, I know that. But this time, let's try something different. So let's try to come up with a universal API automation framework. Is that even possible? So back then, that's where we were thinking. So we were trying to come up with a design. So before coming up with the design, let's try to understand the problem first. So how do we want to see that universal automation framework to be? It should be like, it's a balance between strictness and flexibility. One of the problems with these custom frameworks is they're super flexible, so that they evolve like alien forms, as we have seen before. So how about keeping some strictness? Just like our roads, right? You can travel in the road, but you have to travel in only one way. But you can travel here or whichever lane you want. So we sort of have that balance between strictness and flexibility to help the particular tool to evolve in a more structured manner. And low cognitive complexity, we need developers to focus on business value, production code, and tests should mostly they don't come for free, but they shouldn't be like taking half your release sprint or half your sprint where you're working on your story. And low code, if possible, which is, I think, proportional to low cognitive complexity, and augment manual persona testing. When I say persona testing, they should be as close, if not ideal, to exactly same as how your end user uses. Any deviation, they can't trust those tests, right? And when I think about how do we unify these, there's one thing that sort of is common across all these teams or all these organizations. They all use Postman for manual testing. So Postman has been I hope if somebody is not aware, I'm just going to show Postman in a quick way. So this is how a Postman looks like, and what you do is you sort of have your collections, like this is a REST call, a post call and stuff, and all this is, we call this a collection, and every step, let us say, has a body, and the body will have some sort of placeholders. That's why we call these templates, and you can literally export these and then import, reuse. So you can fire this call, it sends a REST API call just like that. Just a very quick refresher. If you're not aware, you can sort of understand more. So the idea strikes when how about we plug in these Postman templates, which of course everyone uses, and the first thing that somebody writes, because they have to manually test. That's how a developer even starts. When he develops a service, he wants to see that in action. So he maybe have a rough Postman collection, and then he fires it and sees whether it's working. So how about using the same, because the templates has so much of useful information, right? You already keep them in order, and you have all the body, all the templates, and how they are even connected. For example, again, if you're not familiar, maybe you can find it across what is a Postman, but like a particular REST call will populate a particular environment variable which might be used in subsequent collection. So that's how it already has so much of useful information. The problem is we throw away, or if you have, of course, a backend or a JVM based application, it's not easy to integrate this Postman collection in your automation. So they live in their own silo world, and you start writing code again for your integration and end-to-end tests. So the idea is, how about we reuse them, unify them, make them plug them in your automation such that you don't have to redo everything. And that led to the birth of Revom. So it's ReVoman. That's Postman, right? This is ReVoman, and we call it in short ReVoman. So again, now coming back to designing, now we are clear about what we want to achieve. Now let's coming to how should we design it. So we were trying to check out what are the tools available outside before even reinventing the wheel or reinventing the one more framework. And there's so many, but predominantly REST Assured and Postman are the API automation tools, and they're bipolar tools. Like REST Assured is totally a programmatic way of achieving API automation, while Postman is more of UI. And now we wanted to compare best things, good parts from both of these, and merge them together, and that's how we got RevoMan. Now that's how we started to list down ingredients that we need for an API automation tool. The first, of course, is API protocol support. It should support the API that you're using, maybe REST or SOAP or whatever. And ecosystem fitment, important that if I'm JVM or Java tool, I should not be like having to learn JavaScript or do some hacky ways to integrate the JavaScript thing. For example, Postman mostly is into a JavaScript world. And programming and dev experience should be easy to learn, and should be sort of I shouldn't be spending time to even understand if I don't know the tool for the first time. I shouldn't have like crazy amount of documentation that I have to go through to understand it. And configurability comes down to like how many buttons and tuners does the tool has to like configure it according to my needs. And CI/CD integrability, so I should be going in a hands-free mode just by plugging my tests into CI/CD pipeline. And reporting is very important. For any automation tool, so you got to find what went wrong in a very clear manner, and also you have to assert. You should be able to assert on the results that are coming out of the tool. So we're gonna. So I'm currently discussing the points. We're gonna see a demo and then see how those points are checked with the tool RevoMan. And it's important that it's detailed, transparent, and ease of assertion on top of it. And version control, I should be able to, because APIs are version controlled, I should be able to have a way to version control whatever tests I have written. So Java tests, of course, we can put it on Git or something. Now I'm talking about Postman, which resides outside. Can I plug them in and use the same version control? And UI, does it have a UI? I'll talk about it. And modularity, so can I break my test? Is it like I have to write a single long big test which runs forever, or can I break my test such that I can focus on the use case? And maintainability and extendability, so they're self-explanatory. So with these ingredients in mind, let's check out how we can do a template-driven testing with RevoMan. So the reason I'm calling it template-driven testing is because like I've shown, they are Postman templates, and they look like this when exported. They are like a massive JSON file, which is of course some 2000 lines long. And before getting into the demo, I just wanted to give a very quick refresher on what I'm testing, so that you will also get a hang of the length and breadth of what we are testing. So I'll also give you a high-level overview. So it starts with, this is a high-level design, so we'll be getting into code soon. So initially have a init memory environment that any Postman collection would have, or you can add up your own environment variables, like for example your own server name, endpoint, and all of that. And of course those will be replaced at runtime by the tool. Similar to Postman again, you would see the pattern is very same, and those will be used to do request response. We have something called pre-hooks, which will be called before these request response is made. So you can have use these pre-hooks to sort of make certain decisions or change some environment variable, just like pre-request things in Postman. And execute JS scripts. This is, I think, the last trick to bridge the gap between JavaScript world and JS world. This tool also can execute JavaScript and then give back the results to the Java layer and entirely abstract it out for the consumers. It uses something called Graal.js, which is also an open source thing. And of course, it always keeps the in-memory environment up to date. And it also helps in type safety, unmarshals your JSON, but it also does it in a very flexible way. I'm going to show you how. It's not same as what REST assured gives, just a JSON to POJO conversion. It also has a lot of flexibility in converting, even if you're, I think I have a noise. Should we close the door or something? Yeah. And there is also, it lets you validate your responses, and validations can be complex. For example, your JSON response can be massive and you want to run some complex validation. We have another open source tool called Vader, written for the same. It helps you validate. I won't be going into details of Vader because that's for a different talk. But that lets you write complex validations, configure those complex validations on top of your response. And we have a post hook similar to the test.js scripts, but yeah, it's a little more flexible. I'm going to show you all. So with all this, it sort of bakes in a full-fledged automation tool, all the ingredients of automation tool, and we're going to see the demo now. And of course, this is an API that a single API single call. It doesn't have a lot of endpoints. One single call that you make and everything happens. You see a configure thing in between. That's the configuration which I'm going to show you how we're going to build. And it's totally stateless. I'm going to talk about those things. I think I'm just going ahead of myself. And so this is how the environment file looks like, the JSON file. I just collapsed all of this so all the noise is abstracted out. This has all the information that you have exported from your Postman, which you can even import back. So there is no change that you have to make. You just place it in your code base. So whatever I'm showing you is from the GitHub repository that I have, and repository of this library, of course. And I'm going to show you one of the tests I have written called place code end-to-end. What is a place code API? So a place code API is something, again, it's very relatable. For example, if you're into this B2B services that you won't need a code before for you to finalize something, right? You sort of call up a sales rep and he tells you, sir, if you buy like 10 things, you get this much discount and all of that. So, and once they are all good enough, they process the code and then they price the code. Pricing again have all these rules. If he is buying like 10 things, you should get like 5% discount. If not, like he should get 2. All of the rules will run. And once it's done, it's going to tax. Tax in India, we have GST and stuff. It's slightly simpler. In US, it's more complex. They have many taxing rules. So you got to speak with a tax engine. But to achieve this, imagine you have this store that you have a lot of services. So you have multiple personas involved. For example, there is a billing admin who sort of sets up how a payment should be made, all those payment gateways and all of that. And there is a product and pricing admin who sets up what are my services, how should they be priced, and etc. etc. He puts those products into the system, into the database actually. And then there is also a tax admin who configures which tax engine I should be talking to, etc. And after all this, you sort of, the end user, the sales rep guy who is talking to you on phone should be able to hit this API called place code, and he should be able to process the code, he should be able to price the code and tax the code, give you back final code in a PDF format. So in order to do something like this in a Postman collection, there are close to like 70 to 80 steps. Again, I won't want to go into those for the sake of time, but there are like multiple collections that I have exported into. That you can see this collection that I've shown you before. This is like for user creation, and this is for this entire place code, and it has multiple combinations. Like when sometimes I don't want to price, I have to skip pricing and skip taxation, all of that. So those also amount to like 1,000 lines of JSON, which has like some 10 to 12 steps. So in the end, I mean, even if you sort of don't understand fully, what I'm trying to highlight is that's like a massive collection. Now, in order to automate that, imagine what would it take to write it in code, like trying to hit every API, trying to set up all the data, and trying to hit this API and assert on the results whether you got the response that you need or not. That amounts to sort of close to just, I'm just talking about one single end-to-end test might need some 1,500 lines of code. Now we're going to achieve the same in so less, I don't remember the code, but that's like, in comparison, it's almost like 90% down. So this is how the end code, the test looks like. Again, this is already in the repository. Unfortunately, you can't execute this because this hits a server that's running on my local. So I'll probably have a local server, a mock server very shortly. But you can see this to demonstrate how this works. So to start with, again, this is the entry point, and one and only entry point this tool has. No confusions. Oh, yeah. And so this is the template path. It actually started a little late. Don't I have some more time? Okay. Okay, cool. So the template paths I've shown you can take multiple template paths, and there are different ways to input environment. Like some environment you can have it in the file, and something you can even dynamically give on the run. Again, while I'm explaining, I don't expect you to become master of this tool. It's only giving you a taste of it so that you go back, explore more, and understand. And you can, like I say, there are tests that you can sort of work around. And this is how you can give these adapters to marshal and unmarshal requests. Now, what is different from other APIs that are in the market? For example, Rest Assured also lets you unmarshal requests. The best part is, let us say if you have a particular, if you have a Pojo and that's residing in a library which you don't have control on, and you don't have the freedom to add annotations, right? You still can give some things called adapters, and we use a library called Moshi, and it lets you build your own adapter for any complex data structure, JSON data structure, in a way that you can sort of marshal and unmarshal your Pojos. It's sort of pretty powerful. Again, I don't have enough time to really go in depth, but I would request you to explore that. Now,
I just want to let you know you have 15 more minutes, including Q&A.
Oh, thank you so much. Let me drink some water. Okay, great. So now coming to the post hooks and pre hooks, right? So like I said, if you are in this Postman world, you will have this pre-script tests, but you need to write them in JavaScript. But what about you have a certain utility already which doesn't have an API, especially that's true for our environment also. Imagine I have to create something which is platform specific in a hacky way, which is not exposed to outside user. I have to write Java code. There is no easy way for me to sort of plug the Java code into, no easy way, it's impossible, into Postman. Now with this tool, I am using Postman templates, but I can write my post hooks and pre hooks in Java. It's pure Java, and it's like a callback pattern where you get the existing step name and the entire rundown. Rundown is like the entire report of all the steps that got executed until that point. And then you can do whatever you want. This is like a dummy thing where I'm just logging what is what. And pre-hooks are very similar, and you also can get the unmarshaled Pojo of the request. Like for example, your entire Pojo turns into in this case, something like place code request Pojo that you can get, and you can have a type safe thing. Like you don't have to, again, JavaScript, you don't have the type safety. You can get anything. But here you can write Java. The best part of Java is type safety, and that's one of the points that you can use to write your pre and post scripts. And they can get any longer, any complex. You can break them and put them outside to sort of. You can manage that on your own. You will get. You need everything that you need to change or influence your upcoming steps in this pre and post scripts. And there are other APIs, like you want to halt on a sudden failure of a step and all of that. And this is the validation part. So you can use a validation like this. Is again a very simple dummy validator, but this is a full-blown library on its own, which lets you write some advanced validations, even if you have nested data structures. So like, for example, if you have a tree-like structure and you have to validate all of them, and even if you have a batch of those, like list of those trees, Vader has a powerful API to sort of let you write those complex validations. And I would really request you to explore that if you're interested. And one more I forgot to, that is pretty much. This is how you can assert back once you get a report back from the run. You can so you have everything you need, and the report is very, very clear and transparent. And this is how the report looks like, where you have all the things. This is for one step, so you can see where it went wrong. If you see at every point, we use something called either data structure. Again, we're so much into functional programming and using algebraic data types pretty religiously. So we have this request failure, and we have response and all of this, and you can sort of check out where it failed and where it passed, and if everything went wrong, you will have a status. I can also show you how an endpoint looks like. Maybe I'll trigger this test, and while the test is running, you will see the entire rundown being printed in your console if you have the logging turned on. So every step you can see what is happening, what is the response, what is the request, and all of that. And you can see such a lengthy run that happened. I'll trigger again, maybe hoping it'll finish by the time we finish our talk. And that is pretty much it about the demo part. I'm not again going into the depth. I'm just touching the main points so that you can go inside and then explore more. And this is how the failure hierarchy looks like. Like I said, at every point we capture what is a failure, like something can go wrong in HTTP, request, pre-hook, post-hook, and all of that. Everything is being reported back so that you can act upon it. And like I said, that ends up having a lot of low code. So imagine doing, like I said, this is all you have got to do to sort of run such a massive collection of things, where your users are set up, your data is set up, and you hit your API with multiple combinations, and you're asserting on each step. So this is awesome, like, because everybody who uses Postman, who has an API which uses Postman, can use this, and then they sort of don't have to write a lot of code. And as you see, we'll now get into the checklist of things that we sort of discussed before. API protocol, we support REST to start with. We don't support all the SOAP and other things, but of course this is the tool is in its infancy state, so we'll be having more and more features going forward. An ecosystem fitment, if you're in a JVM, of course you can use it right out of the bat. In dev experience, configurability, we saw it has so many options, and this is only to start with. We have so many ideas, and we wanted to improve this and add more configurations on top of it based on the features and requests that consumers have. And CI/CD encryptable, it's pretty easy, right? This is like any other JUnit test or whatever test. We have something called F-test. So whichever environment you have, if it's just have to Java CI/CD pipeline, and you can integrate that. You don't need any fancy, with of course rest assured and other Postman also. This is how a Postman run would look like. Right? If Postman also has their own CLI, and as you can see, if you compare the reporting, right, you don't have a lot of information here, and there's nothing much that you can do once a test fails unless you go back and try to replicate and fail it, compared to what the sort of reporting that this tool gives you. So CI/CD, not just integrating, but it has to also tell you what the failure is in a very clear manner. And reporting, as we just discussed. And version control, funny part, you can put this in the code base itself. So we are reusing Git to see all your templates also will be on Git, so you don't have to do anything extra. They're already there. And UI, Postman already developed a UI for us, so we don't have to develop another UI on top of it. We can use Postman itself to sort of configure our templates in a very fine-tuned manner and just export it. Going forward, we'll also support the URL so that that export manual step is reduced. And modularity, whatever I've shown you, I've intentionally added a very big test. So you can have such a big test, you can even break the test into smaller parts, so it doesn't really hamper. And maintainability, so as you can see, there's so much low code and it's very easy to maintain. And extensibility, when it comes to extensibility, right, extensibility may not be on the consumer, but at the same time, because this is open source, that's the beautiful part of open source. If you have a request that maybe the tool is not taken care of, you can either raise a issue on the repo itself, or you can go ahead, implement one yourself, and then that's how we can extend and improve our tool. This tool can evolve. This is like a starting point, and we can add so many great features on top of it. And I would love to see more and more consumption, collaboration, and contribution. And because, like I said, this tool is pretty young. We are willing to give you one-to-one support if you're a consumer, want to try it out. And if you're a contributor, want to really understand what's going on in the library and wish to make some PRs, I would love to even give one-to-one support, or one of our team members can. And you can join the Slack channel if you have doubts, and we would love to provide you more support. And if you're a student and if you're trying to learn what is going on, what would an enterprise tool look like, this is a good example, because it's a low-level design excellence, I would say. We use functional programming a lot, and something that every developer should learn, in my opinion. And here is the end-to-end demo that I've just given, and the coordinates for the Maven Central if you want to use that library, and the repo. And please, please, please put a star if you like this repo. That would help improve and getting into others as well. And thank you so much.